the whole thing. Uh, hey, whole
Hi,
batch.
Vishal.
Hey, hi Farina. So
Yeah,
is it going to be
it
the
will
whole
be in a
batch?
main room. Yeah.
Cool. So let's start then. Hey guys, how are you guys? So let me tell you, we are going to go through MySQL, right? Today you have your MySQL masterclass. So today we are going to discuss generally two topics. One is the basics, like why MySQL, what is MySQL, right? And then like how do you install it in your local system so you can play with it. So today's session is mainly about the basics and as well as your getting the installation done on your local machine. And later, as we move on along, we will go through your the basics, the DDL, uh, you know, how to make the queries, how to create tables, how to make the rows, your foreign key and all. We go through all these concepts. But I'm sharing my screen with you, all of you. Hold on, give me a minute. Hmm. So you can see my screen. So we are starting SQL for beginners in this class. What we are going to do, we are going to start with the basics. And what will you learn through this master classes, like what is database, what is MySQL, what is SQL, what are these terms, what is relational database, and what are databases in general. And at the end, as I said to you, like how do we do the why is popping them again and again? Okay, no worries.
Vishal, just ignore it.
Hmm.
I'm taking the attendance actually. Just
Cool,
ignore
cool.
it.
No
Yeah.
worries, no worries. So then we go to the installation. So first of all, like for the first question is database. Like why do we use databases? Can anyone tell me? Anyone? Like why databases? Anything you know of, you're free to speak. We will want to make it more interactive. So anyone, what do you think? Like what database is? Whatever your understanding of database is, just speak. Or you can put in the chat if you don't want to speak. To store data. Anubhav said yes, sir. To store data. Someone says not able to mute. No worries. If you're not able to speak, you can write in the chat. Collection of data in organized way. Database. Okay. So most of you are somewhat correct. So database is like we do storage. So you can think of it as a storage. It is a storage. Okay. So by storage, what do you mean is storage, as the word says, you can store something. Now the something could be, it could be a text, right? It could be a JSON. JSON is also like your a document, right? And it could be your images. You can store a lot of things in database, right? But now the thing comes, key, why database? Because you can do all of these things without using database as well. So first thing is you have database. Okay. Second thing is, but we can also store things in files. Files as in, suppose you have Excels and Excel, or you said Microsoft Word, right? What we do here in Microsoft Word as well, we are storing the data. So why, if Excel and Microsoft Words are there, why do we need database? First of all, why do we need database if we already have Excel or data Microsoft Word? So you can say Excel and Microsoft is like a like a database. It works like a database. It's like a very earlier adaptation of how database looks like. You've seen earlier what you have is you have all, I think you have, all of you been through a college, right? You have done attendance as right now Farina is doing. She's doing the attendance. All the things are technical, but I'm talking about earlier days when there is a register, right? So what happens is your class teacher comes, she marks your attendance in a register. They have your name, or each student have a roll number, and you have name, and then what you have, present or absent, right? P or A. So suppose roll number one, name Abhishek. Abhishek is generally the roll number one guy who starts with A, and then it is present or something like this, right? So this is like the very basic implementation of database. What we are doing is we're storing data. So even the attendance and all, this is like kind of database we're storing. We're creating entries, right? We have these entries and we're storing it. Now suppose this is how we generally store data, right? In the early days. What happened? But as this entry grows, suppose each day, we have one entry for each day, right? Now suppose for 365 days, 365 days, we have only someone raise an hand. Of course, and what do you want to? Sir, your screen is stock. Sir, screen. Sir, you're typing something because we are seeing only Chrome. Hold on. Is it okay now? So what are we saying is we have database, right? So I said ki Excel and Microsoft are like, you can say these are somewhat like the earlier version of databases. But as we go on to the like, I'm going way back, or let's say when you were as a child, right? You have studied, so you have a teacher, right? So teacher, what you do? She marks your attendance, or he or she marks your attendance in a register. So what the register has is this is how it looks like. Roll number 1, Abhishek, present or absent column. So these are 3 columns that your teacher has. So similarly, she has like a register could consist of, let's say, 100 pages, right? 100 pages, its limit. It's the limit of how much it can store. It can store 100 pages. And in 1 year, you have 365 days. Suppose 200 days are working days. That is like a rough estimation. So for a teacher, she needs like 2 register to have this, to have 1 year of attendance, right? And if suppose I want to see like when is Abhishek present or not, how many days Abhishek has come. Abhishek, how many days he has come in the college? He has come. He has how many days he comes in college or school? I would say. So she has what she needs to do. She needs to go through all these 200 pages to see like how many days he's present, how many days he's absent, right? So this is like a very tedious work. This is like a very, it is, it generally works, but it is very tedious work if I need to check like how many days Abhishek has come. Or suppose if there is something, let's say school rewards someone who has 100% attendance. If there is a criteria that school rewards someone who has 100% attendance, so I need to check all, let's say there are 30 students in the class. I need to check for each student for all the 200 days whether he comes or not. Then I have to check like it's 100%, right? So see how tedious this work is. This is like to be manually managed without databases. Now, what we have done is in 1970, this problem is addressed through something called databases. So the SQL databases are come in the 1970s. 1970, what happened? They have think ki, most of the work, even you see the stocks and all these are managed through your, they have book ledgers. They store everything in the ledgers, all the price of the stock and everything you think of that needs to be stored, that is stored in normal books, like what do you say, uh, big books of, and even if you see in the government offices, na, they have files. See, they have large piles of files. They have piles of files, and that have like information of records. They might be criminal cases. They might be, all the data they have, evidence data, and all the data they have in the files. Earlier they have at least. Now you can see it in the government office. They have like huge piles of file that are like, occupied with dust and all. So that is what happened. But it is not an efficient way. It is not efficient because, as I said, the problem is if I need to go check like which student is 100% attendance, I need to go through 200 pages plus need to check for, it's multiplied 30 because I need to check for 30 students. So you see like how much work I need to do just to find like which student is like 100% attendance. So computer scientists come, they think what should be done for this? This is a problem. They think, yeah, this is a problem. So something should be done for this. So they come with the concept of databases. So what is databases is a way of storing. The thing is we are storing in this format, we are also storing, but we are not just storing. We there is a certain format of storing also. There is a query also. there are certain factors that make it more efficient compared to your manual process. Now there is one more thing also. There is storing thing, like storing can be done in two ways. It can be done in, let's say, first is your files, and second is your what do you say, databases. So we are talking about storage right now. So first thing is your files. Files is, let's say, anything a.txt, or I would say abc.xl, right? This is your file storage. We are storing in, we are different file formats, or abc.word, whatever, right? We are storing in this format. So I think all of you have done use Microsoft Word or Microsoft Excel. What you've done is they also have these columns and rows. Suppose you want to store name and column, name, roll number, same thing in the your files, name, roll number, or whatever, we'll say present or absent, right? So this thing is done in the file format. So I can make like a file a.txt, and I can do this a1 roll number, like normal Excel you have. Roll number one, name is ABC, whatever. And present or absent, I can mark it whether he is present or absent, right? But again, this is one format, or this is one way of doing it. But there is a issue, like why file doesn't solve our thing. Suppose now again, same thing. We need to check which user is 100%. Which user is, let's say, 100% attendance. We have same criteria. We need to check like which student is 100% attendance. And we need to go through, see, this is efficient because now traversing, first of all, your data will be at one place, you can say. Suppose there are two registers, first you need to fetch like how many registers there are. So manual process is like very tedious. This is files process is a bit, you can say, bit efficient, but not as efficient. Suppose I am saving 360 file again, 365 files again, or you can say 365 tabs of Microsoft Excel, and I'm storing which student have 100% attendance. Then again, I need to go through each 365 files. But right now you have some, let's say, in Excel also you can create your mathematical equations and you can find it. But still you need to go check for one file at a time. You can find it in one file, but for 360, there is no way you can go through all 365 files at one point of time, right? So now comes database. Database says, okay, hold on, I'll solve this problem. So what database do is, database has all these things. You can store, but you can not only store, you can retrieve also. And retrieve means you can find, and find in an efficient way. When I say efficient, I will tell you what I mean. Suppose a database, they comes with this thing, files thing, like the Microsoft Excel, but they also come with SQL thing. SQL is what? SQL is your structured query language. Your structured query language. It means you can query things now. Query, what is that? So query be, as they say, this is a language, structured query language. You can say this is a language of database. So database understand in a particular language. Suppose we have created this attendance thing. We have created a table. We have created a user table. Okay. In user table, we have created roll number. Same thing what we are doing. We are doing name, and then we are doing present or absent, present/absent, whatever. This is a boolean. We will come to what data types there, but for now, just think this is a boolean. Okay, boolean is like true or false. So roll number one, name, Abhishek, and present, right? Present. Plus we have also one format, one column of date, his date, and date could be, let's say, today's date, whatever date is 23 Jan. So for on 23 Jan 2022, he is present. Okay, so now same thing. Now I need to find which user has 100% attendance. Now the thing is much better. I can do one query. I can do select star from users. Forget about the query for now. We'll come to that. But for now, I'm telling you how it makes things efficient for you. I can make a query select star from user whose name, or I can say there are functions, like there are number, there are maximum functions. There are so many functions that I can use to fetch this data, and I can filter out from date and all. So this one query will run, let's say, for 3 or 4 seconds. In 3 or 4 seconds, I am getting my work done, for which in files I might be taking hours, and in your manual thing I'm taking might be hours or days, you can say. So this thing is taking hours and days. This thing is taking minutes, and this thing is doing in 3 or 4 seconds. So you see how much time database are saving for you, right? So that is like the general gist of thing that I have given to you, like why databases. Okay, so you should know like why databases. If someone asks you like why database, okay, so you should be able to tell him ki there are ways of doing without databases. So another thing, when we compare it with file storage, na, storage is not structured. When I say not structured, it means ki you can store any kind of data. So let's say you have a name, you can in the name you can write something like this number, or you can say this hash and all. So there are no validation in file storage. Whatever data you have, you can store it in however you want it. But in databases, the beauty of databases is you have data types. Means you can say, let's say name is of type string. Okay. So when you mention ki name is of string, so you cannot store this thing now. It will give an error. You cannot store this thing now. Anything like uh, any characters, this will give an error because you mentioned ki data type should be string. So another thing, data type advantages, data have structure. How your data is stored, you can tell the database it's going to be in string. Suppose email will follow a certain format. Email will be ABC. It will have a @ it will have a Gmail, and at the end a domain .com or .in or whatever, right? So these things you're telling to your database. Now, since you have a structure, now you know what kind of data you have. There is not going to be any random data. So since it has a structure, the query is going to be efficient, making query, because here there is no structure. If someone, let's say someone put any, by mistake someone put something, no? So how would you know? Even if you like, you will be getting confused, why did this happen at the first place, right? So it's better this should be structured. So another advantage that database is that they are structured. Now we'll move to the part like what is database. Okay, so in general, you have seen dictionary. Dictionary is like the very first database you can think, and dictionaries are like a very good example because it covers a lot of things. Suppose you want to find a word, the word is abacus. Okay, but you have indexes. Let's say A, right? Then in dictionary has A B, then A B A, then A B B, right? Then A B C, then A B D, whatever, right? And it goes on, like dot, it goes on. Okay. So what you do is, let's say you want to find a word abacus. So first you will see where are the A words, right? Then you go to A or AB. You see the second word start with AB, you go with AB. Then you check for the third word. Third word start with ABA, right? So you need not to go to all the alphabets, A, B, C, and all, right? So suppose your dictionary has, suppose dictionary is 1,000 pages long, right? And what you want to find abacus is might be on the 57 or 60th page. Let's suppose 60th page. So you need not to go to all those 100 pages. Even you need not to go through 59 first pages as well. 59 pages you did not need not to traverse. What you need to check is first go with A, might be first page here, okay, one page here. Then you will check AB, okay, one page here. Then you check ABC, another one page. Let's add one page, and then ABCA. Okay. So at the in 4 pages, you just traverse, you flip 4 pages, and you find your word. In 4 pages flip, you find your word abacus, right? So you need not to go through first 59. You need not to go through all the 100,000 pages. See how efficient that is, right? and that is your indexes actually. That is how indexes work in any database. Indexes, what they do is, just like your dictionary, you need not to go through everything. You just need to check ABC, in ABC, and in 4 pages, or you can say in 4 traversal. In computer science terminology, you can say in 4 pages we have find the word abacus. Okay, so that is your indexes. That is the concept of indexes. We'll come to that part later, but for now, at least you know like how like searching is fast in databases. Okay, so these are like real life example: dictionary, telephone book, or you can think a lot of things. See, everything you see in today's world is stored in a database. Everything, your Facebook, whatever in Instagram you upload your photographs, they are stored somewhere, right? They're stored in a database. You in Facebook, you chat with someone, you send a message on WhatsApp. Even coming before in this session, you might have got some messages, right? They are stored somewhere. That is a database. Everything in today's world, everything you do, it has an implication of database everywhere. Databases are everywhere. So you can find a lot of examples. These are like the very common ones. But in today's world, with the advent of like technology, everything is stored in databases. From Facebook to Instagram to your Google social login, whatever. Everything is stored in your databases. Okay. So these are like the general example where databases are used. Now, again, next question is why we need database. Okay. As we said, I've given you example. If we follow the manual process of storing in registers, right? So you see that how hectic that is, right? So these are like few pointers. So to keep records of client, okay, it's a data like client staff, or in suppose let's say in function up, right? Function up, you're students, right? So we need to keep the tracks of all of you guys, how you're performing. We can store that information in your database. Or suppose to keep sales record. Suppose Flipkart, how many products they are selling, they want to keep tracks of who is purchasing what, at what point of time you're purchasing. All of these data is stored in your database. Develop reports, and on these sales, we can also create pie charts like how the reports went. So if you have database, you can create this analytics and all. These are like the few things. But apart from that, you can store whatever you want to store. Suppose you can give me any example. I can tell you like how database is used. Okay, we have sir MySQL SQL में क्या difference होता है? Okay, we'll come to that. We'll come to that part also. I'll come to that also. Queries method of fetching with some attribute. Yes, that is correct. String is a data type. Someone is asking, sir, we have worked on MongoDB. Okay, so I'll also compare with MongoDB. Okay, how MySQL is different. Image. What do you mean by image? Okay, image is also, you can store the URL of an image. Suppose HTTP, whatever image you have, that URL can be stored in your database. So yeah, that image you can store in your database. Image has a particular URL that we can store. So next thing is structured query language. Someone is asking ki you have done MongoDB, right? So what I'll also do is I will compare how your MongoDB and SQL, what are the similarities there, and like what are the differences, and like what are the advantages of using SQL, or what are the advantages of using MongoDB. I know both of these things, so I can give you a better I can also give you a comparison like where you should use what. Okay. So now we have come to the point ki we have databases, right? Okay. Now database also can be divided into two things. People also ask you what is relational. This is like a very interview question. In relation, what are relational databases or what are non-relational databases? They can ask you these questions. And there is two terms also used with relation. They use SQL databases. So don't get confused. These terms are like used with the same thing. So if someone is saying relational database or SQL database, they're referring to the same thing. If they're referring to non-relational database or NoSQL database, then they might be referring to the same thing. Hold on, just give me a noise coming from it. Okay, I'll take care of it. So these are non-relational database. The another term that used for no relational database is NoSQL database. So as someone is asking like what is SQL databases, database queries, we come to that. We'll come to all of your questions. Don't worry, don't worry. Rajesh Kumar Dev Sharma, we'll come to your questions one by one. Okay. So we are talking about SQL databases and NoSQL database. See, in 1971, 70s, this term called SQL. SQL is what? It is a standard in which you store like the table data, tabular form. In SQL, you store data in tabular form. Means you have a row and a column. There is a row, there is a column. I can show you my screen. You guys are seeing my screen, na? It is the only screen you're seeing. Or hold on, let me show you what exactly it looks like. So here. So suppose what we're doing is this is workbench. We will come to that part also. Suppose for now this is attached. I'm creating. So this is, let's say, a table. Okay. So what I've done is select star. So you can see in database. I'll enlarge my screen. This is your table engine. What it looks like is, suppose this is ID. This is user ID. These are name. So these are your what do you say? This is one row. Okay. This horizontal. This is called row, and these are column. ID is one column. User ID is one column. Name is one column. Type is one. Location is one. Size is one. Extension is one. Okay. Suppose we will open this user collection. Suppose. So in user, let's say ID, email, password. Password is hashed name, area code, and all. These are what do you say? And this is one entire table, and this ID represent one column. Email is one column. Password is one column, and the entry of one student, right? In this, in all these columns is called one row. This is one row, one admin and all. For one candidate, one record is called one row in your SQL. Okay. And I will also show one interesting thing to you. So these are column name you have. So this is generally like ID, name, email, password, name, area, phone code. So these are your columns names, okay? And the data type. We'll come to that part also. But for now, just forget it. It's like normal. You have types in your any programming language you have read. Just we'll come to that part. Don't worry. Okay. Sir, please font size increase. Not showing properly. I'm getting problem in installing MySQL. Okay, we'll come to that MySQL part. I don't think. How can I increase my font size? Okay, let me try. Because I'm not opening this in browser. I can, this is like a proper MySQL. I think you will be able to see like, okay, no worries. But the thing is you generally know like what it is, right? I don't think we have option of increasing our font size here. Yeah. I can increase from the browser, I know, but so I'll just zoom in. How do I zoom in? Is there option in your, what do you say? Optimize for meeting breakout rooms. I don't think we have an option in our, what do you say, in our Zoom. Zoom doesn't have option. I can use migration, but migration will like make it much hard to handle these things. So there is nothing to be like worry for now. Okay, just think of it like a, okay, I'll do one thing for you guys. Why don't we open SQL tables? I can open zoom it here. Okay, so don't get like, if you're not able to see it, don't worry. We'll come to that. Okay. So they might have some tables here. SQL tables. So you can see this thing, right? I can zoom it out however you want it. So suppose Suppose this is what EID is, no? Now fine? Or SQL versus MySQL. We'll come to that. No worries, no worries. Control plus ain't working. It won't work it here. But don't worry. You can see it from here, okay? So this is your column, okay? And this is one row. So for Sam, this entry of Sam, one Sam, 95,000, 45 male operation. This is row. And EID, E-name, E-salary, E-age, E-gender. This is column, okay? So generally SQL what has is, it is stored data in a tabular form. So table consists of a column and a row. So column is all these things: EID, E-name, E-salary, E-age, E-gender, E-department, and Sam 195,000 his age. Bob is one row. Sam is one row. Bob is second row. Anne is third row. Julia is fourth row. So this is how your row works. Okay. So you can see my screen, na? Or you don't see my screen. Screen not visible array. Okay. Hold on. So now can you see my screen? Yes. Okay. So what I want to tell you is that this EID, I can also zoom it out for you guys. So suppose this EID, na, this is your this is your column. E name, E salary, whatever you mention as a E name, E salary, E age, E gender, these are your columns. And this one entry, one Sam 95,000, this whole thing, this is your one row. And second Bob, this is one row in your MySQL or SQL database, you can say. So columns, and these are your rows. Okay. So that's about it. Now we'll take some questions. I think you guys have lots of questions right now. So someone is asking SQL versus MongoDB or RDBMS versus DBMS. So DBMS and RDBMS is there is no difference. Like DBMS also consider of these tables, and RDBMS also consider of these tables. The only thing is ki relational databases. You can think of it like a advanced thing. Advanced, like what I mean by that is ki there are relational. So what are relation? Because the only difference is here is relation, right? So what kind of relation we are talking about? We'll break this down for you. Suppose each thing is divided into, okay, what is DBMS and RDBMS? Like relational database is the advanced version of database system that allows you to arrange, maintain, retrieve, manage database in a tabular format. It is one of the most used tools by data analysts. Okay, there is nothing much there, but I'll go one step deep. Suppose what your DBMS is, DBMS is same thing, but we have relational. There is something called ER diagrams. ER is there is an entity and there is a relational. Okay. Suppose two things. User, there is a user, or you can say student and teacher, right? What is the relation between student and teacher? For let's say what is the relation between you and me is I am teaching you, right? That is our relational. Okay. So on the basis of relation, we form our tables in a relation RDBMS. We call this as ER diagrams or ER mappings. You can say ER mappings. These are entity relation mappings. So when you go through like relational database, you will go through this mapping of ER. So this is whenever you have a like a relational database, no, there is a relational model also. So this is also one of the first thing that has been taught to you. Suppose a person has passport. So has is the relation. We can change this entity here. Let's suppose we change this to student, and we change you as a student to mentor. I'm a mentor and you are a student. So we both have a let's say session is our relationship. So we have a one to many. Like one mentor can have many students. So our relation is one to many relationship here. So a mentor can teach many students, right? So our relation is one to many. This is how like relationship are a breakdown. We'll come to that part also. But for now, you can think of a relationship as in relation databases, you have relationship. And relationship can be between any entities, any two entities, two or more than two entities. That is how we divide it. But for now, this is how relationship is. This is how relationship can be understood. Okay. So now coming back to this part, this is the RDBMS part. So what is MySQL then? So MySQL is also one of the SQL languages. Someone I think asked Oracle also. Oracle is one of the SQL like providers, you can say. Oracle SQL, we call them like Oracle SQL. So it is owned by Oracle, the SQL language that you have. So SQL is actually a terminology. It is a standard, okay? But they, whatever their databases, they also called it as SQL. So there are two terms here. One SQL is, this is their product. This is the product of Oracle, okay? But there is also one term SQL. This SQL is used as a standard. Whenever someone say you SQL databases or NoSQL databases, they're talking about SQL as a standard, okay? But when you say Oracle SQL, then we are talking about SQL as a product of Oracle, okay? So there is a differentiation there also. So this is a standard. Standard means ki there is a two ANSI. ANSI is your American National Standard Institute. It will standard every in like the standard things for you. And ISO is again international standard organization. So they standard things for you. So SQL has become a standard right now. So whatever we say SQL generally consists of MySQL, your PostgreSQL, your Oracle SQL, and uh, all these query language, they're combined into SQL. So SQL is a standard, okay? And when we're saying Oracle SQL, that means we're talking about the product of Oracle. They're two different things. So SQL, whenever someone asks you SQL versus NoSQL, they're talking about SQL as a standard. Okay, let's touch a bit on that part also when we're talking about SQL versus NoSQL. Okay. So I'm taking you back to this thing. So we're talking about SQL and NoSQL. So in 1970, your SQL came, like it is the earlier you have SQL only. So they have they said ki what we will do is we store data in table format. Which we have is we have a row and a column. Okay. And I've also given you example. Suppose ID, name, roll number for now. So ID1, name Abhishek, whatever, ABI, roll number, again one. Okay. So this is like the, but in 2000, there is something called NoSQL comes out in the 2000 or late 2000s. So it is like earlier we have only SQL, but now we have NoSQL. So the point of having NoSQL is ki in your SQL, things are in row and column. Okay. So if you need to, there is no way you can store array. There is some certain limitation to it. Means suppose you want to store something. Suppose one person has two addresses. Means he has one home address, okay, where he is from, or one where he's working, his working address. Okay. So in MySQL, if I need to store this information, so the in person with person has one to many. One person has many addresses. Okay, so there is one to many relationship here. One to many relationship. And relationship are one of the most important thing when you read any SQL databases. That is all how you understand like how databases, how SQL databases work in general. So for example, you have one person, many addresses to store this information, right? Since we have only one row, okay. What we do is suppose his name is Abhishek, okay, Abhishek. If I store this information, name Abhishek, addresses, suppose his address is, this is his address of Delhi, but he works in Bangalore, so he has another address, his working address, as this is Bangalore as his working address. Since if I need to like query like which Abhishek, you see name Abhishek happened twice, right? So if I want to query, I can get maybe Delhi, maybe Bangalore, right? So what you're seeing, there is a redundancy. Redundancy means there are duplicates entries. So name Abhishek appeared two times in this thing. So redundancy also it's not considered as a good thing. If you redundancy is considered as a bad thing. If you want to store database, any query, so make sure that the data is not redundant. So to store this kind of thing, what we do is we divide this thing into two tables. Suppose one table is about user, another table is user addresses. What we have is we have Abhishek here and his ID, user ID 1. So what we'll do, we have one entry in this in this table, another entry user 1, address Delhi, and user ID. Again, let's say user ID 1, another entry of user ID 1, and this is for Bangalore. But someone can ask if we are doing the same thing here, like what is the difference? There's a difference actually. What we are doing here is we have, suppose in this case, we have other information also. It could be his email, it could be his address, it could be his date or whatever. You can say his. So I'm storing his email, I'm storing his address. So all these things are going to be repeated, right? But when we have ID only, and suppose if someone he changes his, suppose he change his name Abhishek to, he has changed his name Abhishek. Suppose she's a girl, okay? She has to change her name now because after married, what happens is marriage. Generally, like someone has to change her name. So she becomes, her name is Alice. She becomes Alice John, whatever. Okay. So Alice has to change her name. Now I need to change. Suppose there, if she has 100 addresses, right? I need to change her address. I need to change her name, her email, her address in 100 entries, right? So instead of doing that, what I could have done is, I have this user, one column as a user and his ID. I can only change his, I don't have to change anything here in this case. I can only change Alice. See, Alice John. Now I need not to change Alice John everywhere. I just made one change because we are referring to ID here. Another thing is whenever you refer to ID, not to name, the benefit is of update. Whenever you update, uh, you don't have to change anything because one has no significance. One has significance only because one is mapped with his name, Alice John. Okay. One here doesn't mean anything. One in itself, what is one? One is just a number, right? But now it makes sense because one is attached with Alice John. Means we know that Alice John has a user ID of one. So this one is mapped with his user ID. So that is how we store things in what do you say, MySQL or SQL databases. In no SQL database, there is no concept. You can store directly arrays. For example, if I want to store the same thing, what could I have done is, I have name Abhishek. And I can only directly do his address because address is an array. We can store arrays. That is a great thing about, you can you can store a whole lot of things. You can even have additional fields in, suppose I can also store one thing that is like is online or not. Okay, I can store this information, and this need not to be like present. It could be only for Abhishek. I can store this information. It could not be for, let's say, Alice. But in MySQL, there is no such thing. Because there are column is going to be applied for each row. Okay, so whatever columns are going to be you make, they are going to be applied for each row. So you cannot manipulate that. In MySQL, you can do that. You can have any keys. You can have additional keys that cannot be present in other documents. But in MySQL or in MongoDB, you can do that. So that is the beauty of NoSQL. You can add these keys, So you can say the structuring is more dynamic in your NoSQL, and we will refer to MongoDB. Even what they say, let's refer to their doc. So this is NoSQL versus SQL databases. MongoDB has made a comparison. So they're saying what? They're saying NoSQL database were developed in late 2000 with a focus on scaling, fast queries allowing frequent application changes, making programming simpler for developers. They're talking about relational databases also. Relational databases accessed with SQL were developed in 1970s. They're saying the same thing कि ये earlier थे, and they focus on reducing data duplication. As I'm saying, कि इनका their focus is to remove this redundancy. You're saying, okay? So their focus is removing the redundancy. So they're saying that their focus is to remove the duplicate data as storage was more costly than developer time. SQL database tend to have rigid, complex tabular schemas. Again, the same thing. If let's say you want to update something, you need to update hundreds or thousands of rows if you need to do that in SQL. So that is your SQL and NoSQL database. These are very interview questions they're going to ask. and it is going to be a very good. You can go. I'm sharing this link with you guys. You can go through this. So hold on. I'm sending this link to you guys. So yeah, you can go through this like what NoSQL and SQL database is. You can learn for yourself like what it means. It's a simpler thing. They make a comparison to in 2000s and in 1970s. What has happened? Okay. Can we store object in MySQL? Yes, you store object in MySQL. The JSON is the object now. Sir, will there be any differences between different relational databases? Yes, there is a difference. So there are differences in types. There are differences how you make queries. For example, if you take example of MySQL and PostgreSQL, right? There are because PostgreSQL is different language. MySQL is a different language, so there are differences there. There are differences in types also. Some of the types Postgres has different and MySQL has different. So yeah, they have different things. Okay, so now that is the NoSQL and SQL databases. So from now on, we are going to be more specific on the MySQL. Okay, so I'm going to be telling like why MySQL is. So for MySQL is like it's open source kind of thing. It's like a community thing. So Oracle is owned. Oracle SQL is owned by Oracle, but MySQL there is one edition called MySQL Community Edition. Okay, so this is about how you install it. Suppose you go to MySQL, there is downloads thing. Okay, in the downloads, they have given you MySQL cluster, like which one you want to download. I have also information on this. I can share with you guys. So this is downloading. So you go to www.mysql. This is www.mysql.com. Then you go to downloads. Okay, and there is MySQL Community GPL. So this is the edition what you want to download. I'm also sharing the link with you guys, so you can go through this link. So I'm in the chat. I'm sharing it with you. So you guys also will be aware. Okay. So what we do is I will copy this link and we'll paste this MySQL GPL Community Edition. So the one that is MySQL has this free version that you need to use is this community. They call this as community. This is for community means anyone from the community can use it. So there are two things here. They have the Windows x86. This is the architecture of Windows. What kind of architecture you have? So some of you have 32 bits, some of you have 64 bit. Okay. So this is generally for 64 bit. So Windows X 86, 32 or 64 bit MySQL installer. You can use any of them. So one is 223 MB, another one is 657 MB. So this thing is they have debug binaries and test suite. I don't think you need that. So you can use this version only, this 223 MB version, 8.0.32, whatever. This is the latest version of MySQL Community Edition right now. So what you can do is, and for Mac users, okay. So Mac users also, this is for Microsoft Windows, you can select your platform. So suppose if you are on Ubuntu Linux, you can select that. If you're Mac OS, you have your DMG image. So in Mac, you have the DMG image or tar, however you want to use it, but use this DMG. DMG is like generally install and you can use the DMG image. Then for Ubuntu, if someone use Ubuntu or say Debian, let's say Ubuntu, we have this file DB package. So they have different package. If you are on Ubuntu, that you can use the command line also. In the Mac, you can also use the command line, but I would say you will use this thing because sometimes it's better you do it from this because there are different sources that provides MySQL, right? And they might be malicious from where they're downloading the file. I would say go through their official thing. This is their official provider. There are also links that give you the MySQL community downloads, but they're not from their official site. So I would say go through your official site, select your operating system. Then you can also type like what kind of OS version you have. Suppose Mac OS, they have for ARM. So now Mac also have your M2, right? Mac they have the M chips, so they're ARM based chips. And if you're using an Intel chip, then use this x64. These for the Intel chips, and these are for the their new ARM chips. M1 or M2. Use this for this one for this. If you want to do all, they will select all. If you want to be specific for ARM, they will give you for ARM only. And x86. Don't use the x86 on the ARM machine. If you're using a M1 or M2, use the ARM, because you will there will be issues when you use x86 architecture on an ARM machine. Similarly for Windows also, you'll get these things. Microsoft Windows doesn't have anything because they have the Intel generally and they have AMD, but there is no difference. ARM has a architectural difference. That's why they have different binaries for ARM and your Intel. And once you have downloaded it, then they will ask you for installation. Set your password, okay? And once password is set, then you have this thing. This thing will open. This is their GUI. So this is called MySQL Workbench. So when you install it, Workbench will be there. I'll show you guys what Workbench look like. This is your Workbench, MySQL Workbench. This is the GUI on which you might use MySQL. For MongoDB, you use Compass, or let's say Robo 3T or Studio 3T. But for MySQL, mostly we are going to use Workbench. It is a good like tool. It has lots of things. You can what do you say? You can import things. You can export things. You can import your SQL. You can create tables. This is like a very good tool, MySQL Workbench, and this is provided in the community edition as well. This is included in the community edition. So go with MySQL Workbench. There is also something called PHP MyAdmin. So there is a version. There is a MySQL version 8. Before 8, we have MySQL version 5. Okay. So I would say go with the version 8, because there are changes in MySQL from 8 to 5, and there are breaking changes. When I say breaking changes, there are some things that are added. For example, I said you cannot store arrays, right? But in latest version, you can store an entire object and entire array by stringifying it. And sir, PHP and MyAdmin I have used, good thing. But go with Workbench. Workbench has additional functionality, I would say, because it will give you access creating. You can do all these things with PHP MyAdmin as well. But for that, you need to like first have a, what do you say, create a server. You need to install a server, and WAMP, or could be a XAMPP. You need to install it. Then you need to run it. It actually runs. PHP MyAdmin runs on your browser only. Okay. But Workbench is like the official thing that is provided by MySQL community. So use MySQL Workbench. I would prefer use MySQL Workbench. It is included in the installation. So use MySQL Workbench. So I think that is what we are going to discuss in today's session. Okay. So if you guys have any questions, you can ask. Sir, what is the difference between MSQL and MySQL? MSQL is your Microsoft SQL. MSQL is actually a product of your Microsoft. MSQL, or is there anything like MSQL? I think Microsoft SQL. Hold on, it's not showing anything about MSQL here. And is there anything like MSQL? I know it's like a product of anything, but I'm not sure what is Microsoft SQL called actually. Microsoft SQL. Microsoft also have their SQL. So this is called Microsoft SQL. So the short could be MSQL, but I don't think they call it as a Microsoft SQL. This is called Microsoft SQL. Just like Oracle has their SQL. Microsoft also have their SQL. So MySQL is an example of SQL database. Yes, that is true. MySQL is an example of SQL database. That is correct, Nikhil Singh. Questions? Any questions, guys? You can ask anything about today's topic. As the data in MongoDB is stored online on Atlas, the thing is that is true. That is not true. The MongoDB database is stored online. It can be stored online. It can be stored offline as well. Okay. So if you're storing it online on an Atlas, means you're storing it on Atlas server, right? You can store MongoDB offline as well. And similar thing goes for MySQL. If you're storing it on your local machine, then it stays on your local machine. If you're storing it on some server, then similarly you need to like provide that what do you say, that connection string And once that connection string is provided, then you can connect your MySQL server. So that is not true. If MongoDB is stored online, MongoDB can be stored offline as well. And that is true for MySQL as well. MongoDB is stored both online and offline. MySQL is both stored both offline and online. Which is better, NoSQL or SQL? See, there is no such thing as better. There are advantages and there are disadvantages. And there is your use case for which thing you want to use. Suppose some things are better in MySQL and some things are better in your MongoDB, for example. And these, what are these things? For example, if there is some requirement that you need to store like a relational database, right? Then MySQL is the best option here. But if there is a database that does not have much relation, like you need to store entire data and it's like you need to store some analytics and all, then MySQL is a better thing. Suppose you want to send notification, right? Or logs, because logs can be deleted or it's going to be highly scalable. You can use MySQL there. How to save to a server in MySQL? See, for connecting to a server, you need to buy any MySQL. Just like Atlas, you have bought a connection string. Similarly, for MySQL, you can use any provider that provides you MySQL server connection, and you can create your MySQL server connection. Once that connection is done, they provide you the connection string, and using that connection string, you can connect it. Sir, which databases mostly use SQL or NoSQL? So there is this. I think they have done this analytics, like how much percentage of MongoDB is used and how much percentage of MySQL is used. So MongoDB is the most used across industry. It's around 18 to 20%, and MySQL is the second most used. So MySQL is can share is 12 to 13%. So they both have like a good usage in the industry, and they also have good documentation. If you want to, let's say, have want to found questions on what do you say, Stack Overflow, so you can find a good solution of both MySQL and MongoDB. So both are good. Is MongoDB is relational or non-relational? It is considered a non-relational database, but we can store relation with the help of references. You have stored references, right? References is just like a relation. You are relating that data with providing that reference. So you're relating it, but it is a non-relational database. By convention, it is a non-relational database, but you can store relational data in it. But by convention, it is considered a non-relational database, MongoDB, Vishal Prakash. Okay, so I think if you don't have any questions, if you have any questions, you can ask. I think we also done our time. And I think we have covered, can we structure data in MongoDB? Yes, you can structure data in MongoDB. Where you have the schema, na? The schema, in schema you use, that is how you structure data. You give the validation. Can we store data in MongoDB? Both database are used to store data. So that is like the gist of database. You have databases means base of data, right? Base means like it is the place where data is stored. That is the word itself means. We have to create schema for SQL or not. We can create, actually, the thing is schema is not created by SQL or MongoDB. You have like a ORM. ORM is, let's say in MongoDB, use a Mongoose. Through Mongoose, you're creating a schema, right? Similarly, in MySQL, you have something called SQLize. So SQLize is the ORM that is used in Node.js. With Node.js, you use SQLize to connect with MySQL. So there is a way of creating schema in MySQL also with the help of SQLize. But I want to mention this: MongoDB, like the native MongoDB driver and the native MySQL driver, you cannot create schema in this. ORM provide the functionality of creating schemas. Can we store structured data in MongoDB? Yes, you can. So schemas are used to do that. If yes, then why we use SQL? See, the thing is, why we use SQL over MongoDB? I said it's because of relational database. Suppose some things are relational. Like I give you an example of, let's see, if I want to store something that has relation, means in general life, there are two entities, right? And two entities could have relationship. Suppose I teach you, I teach many students, right? So there is a relationship. Like I teach you, so I can store my data in a mentor table and your data in a student. So I can reference all of you like student name 1 2 3 4, and I'll pass my ID. User ID 1 2 3 4. Same thing we can do in the MongoDB as well. But there are other properties as well. These are the ACID properties, like how consistent the database is. We will come to that part also. But for now, uh, why we use SQL is you can think of it because of relational database. It's a relational database. That's why we use this. Can we use MongoDB and MySQL in same Node.js application? Yes, you can use a hybrid of both MongoDB and MySQL. Most of the big application, they use many databases because their requirements are different for different things. Suppose they use, suppose let's consider even Facebook, or they're using many databases or many levels, because few things have a use case. This could be done better with MySQL and this could be done better with MongoDB. So they leverage whichever is better, they use that. So yeah, you can use it both in the same application. Even more than that, not just two, you can use, let's say, 5 or 10 database also. There is no limit. You can use as many you want. Okay. Any more questions, guys? If you have any doubts, you can ask. Like, just and if we don't, if you're satisfied, just post something like, yeah, we don't have any more doubts. Or thank you, sir, for the session. Yeah, thanks for your time, guys. It's really nice for me, you know, to. I want to like tell you much more about databases, because database is something that I have an expertise over. Okay, I can tell you even in deep, like what in more about databases. So yeah, it's good to connect with you guys. You've all been great. So I think I might have tell you something useful today that you might use in your interviews. Okay. So yeah, keep practicing and keep playing with it. All of you first install today, just install MySQL and play with it. Like create something. So might be in the next session or anytime we can. You can have like a better understanding. You can even ask me more question about it. Okay. So go explore it. I've given you the links. Install it and explore it. And on that note, good night, and it's a lovely session. Bye bye. Bye bye.